is work on flooding, forecasting, and monitoring using open source Earth observation data with regionalized EF hydrological model for Eastern Africa. And in the interest of time, I would request Calvin to be very, very brief, take about 10 minutes, present mostly the methodologies and the outcomes and discussions, and then we can have one or two questions. So welcome.
Thank you, Eric, for that wonderful introduction. Good morning, everyone. As Eric has indicated, my name is Calvin Swara. As Eric has indicated, my name is Calvin Swara. I work at the Regional Center for Mapping of Resources for Development as a thematic lead on water and hydroclimatic disaster in a severe program. I would like to take you through some of the work that we are doing that are more relevant to this theme, and that is the application of Earth observations in flash flood monitoring and forecasting within the East Africa region. Next. Next. So one of the challenges that we have experienced before is, being able to characterize hydrological behavior and forecast flood with the precise time that are required to respond to necessitate certain response for this disaster action. Next. Flood is a common hydrological problem in the region, and is one of the most destructive. Can I request you to put it in a presentation mode? In a presentation mode, please. So go back. Yeah, next. Thank you. So flood is one of the problems that we have in the region, and there has been a lot of challenges in terms of trying to focus it so that the humanitarian disaster and response strategy can be developed in good time to save certain lives. So what we are doing in the region involves development and implementation of a regional flash forecasting system that would enable to generate informations that would be used for various response strategy, and also to support the decision-making process in response to flood disaster. We work with various stakeholders in the region, in Kenya, Uganda, and Tanzania, where in Kenya we work with the Kenya Meteorological Department, Water Resources Authority, and Kenya Red Cross Society. In Uganda, we also work with different organizations that are mandated to perform that, and also currently we're also in Malawi. Next. So the science of these work we're doing involves two folds. One of it is, being able to characterize the rainfall runoff module, and also harvest or utilize the various weather forecast products that are provided by various satellites to give some information. So the conversion of meteorological focus into hydrological focus in what comes into the flood, and in doing so we use an ensemble framework of flood flash forecasting system, or the framework that takes the input of the land use, soil type, and various forcing file from hydrometeorological data, including digital elevation modules, and gives an output in terms of flood inundations, stream flow power, soil moisture, as well as the water depth. We use the global focus simulation data that are provided. It's freely available, and we force this on this hydrological model with a near real time of IMAG to provide a forecast variable that includes stream flow as well as soil moisture. And the stream flow and the soil moisture can be used. Soil moisture can be used in the prediction of drought, but in this particular presentation is for focusing of the flood that we used in this. There's some post-processing work that is being done to determine at what point the flood exceeds a given threshold, so that a early warning or early messaging system can be developed in place to notify the relevant authority in terms of the occurrence in location as well as the time of an impending flood. Next. And all this computation is taking place in the cloud, given the huge data amount that is required and the area coverage that you're working on in Kenya, Uganda, Ethiopia, Somali. This is a very big footprint. So we are using a DM or a digital elevation model of 500 meters grid, and then we force it with this meteorological data that I've talked about to provide a certain output. We calibrate the output of this model using observed river stream flow for various gauge stations that are provided, but also we also calibrate the model used on Dartmouth Flood Observatory that provides, in terms of the polygon shapes, the occurrence of flood, in terms of locations and timing. So all this data we use to calibrate this model so that it can be reliable and the output can be easily usable. Next. So the model as a visualization platform that is developed to give us some indications on the spatial area as well as the timing that this occurs. And also, in terms of timing, it gives you near real time as well as going back into 10 days that is provided by the global forecast simulation system. We'd be able to characterize where this flood happened and at what time they happened. The accuracy of this is being validated and collaborated with the information that we obtain from different media houses in terms of when flood occurs, or they provide the report, or the Red Cross report that gives detailed information based on their field activities in terms of location where these floods occurs. Next. So we use the model again to characterize one of hydrological phenomena that happened in West Pokot on the 23rd of November 2019, and we look at how the model would be able to pick, where the model was in a position to be able to pick at the landslide that happened in the Western Pokot. Next. So in this particular case, we locate the villages that were impacted by this landslide. And this landslide would be able to track in time what happened before the landslide and then after the landslide. What is the amount of precipitation that necessitated, the soils in this area to be highly moist and to be fluidized to the extent that it slides downstream. We do next. So in West Pokot, there are villages that were impacted, and we look at how this happened in terms of time. Would you just go back a little bit? I don't know why that slide is not rolling. We look at it in terms of the timing that affected. We know that from the media houses, we know the number of people that were affected as well as the time that that flood occurred. It occurred at midnight. We would be able to track from 3 p.m. how the weather was behaving in that particular locations, and also the amount of precipitations that was being received in that location. In terms of, I think there's a video that should play so that the time moves with, I don't know why that's not happening, so that you'd be able to see the area that is in cycle when it's okay, and then when it suddenly turns red. Okay, that's a technical itch, but the locations where the red circle is where the villages, or the locations where the flood occurs, and you'd be able to simulate, when it starts, when rainfall started, there's normal life going on there, then eventually the stream power in that particular location turns to some color that's red, indicating that there's a phenomena that was happening there as well as the timing. Now, in terms of getting this information, we are overlaying this flood information with the existing biophysical data, such as the populations, the schools, the water points, and also the health centers that are most likely to be affected, including the roads, so that we'd be able to tell in time which roads are most likely to be impacted to support certain initiatives that was being done by the International Federation of Red Cross of no-regret actions. A no-regret action is that actions that can be taken. For example, if we know that the flood is going to happen in a given location, then certain roads are going to be blocked. Then things like provisions of medical equipment, provisions of medical facilities, and water boozers can be transported to the other side, such that even if the forecast is not reliable and was missed or was not hit, then it means that those medicals that were taken the other side, so the materials that was taken the other side does not go into waste, but they can also be utilized in the hospital and the water can still be consumed. So nothing really goes much into waste. So overlaying this kind of information is what we're doing currently to develop the wider footprint for this particular region, and also to regionalize this because different areas experience flash flood, the others experience riverine flood. The riverine flood, we can regionalize them in terms of the frequency analysis based on the observed data tied to specific river basin system, so that the accuracy and the reliability of this can be assessed more. Next. So the things that we are currently working on, that solves, make it a little bit more integrated and a framework that can be utilized, to develop a flood notification alert system so that when a threshold is exceeded, then using an Amazon web-based, we can generate an SMS message to the people who are affected or to the institutions that is mandated to give an early warning system like Kenya Meteorological Department in Kenya, so that they can get this information. What they do with this information in terms of an impending flood, they can bring together different organizations, humanitarian organizations, that Red Cross that works in the region to respond to such disaster. We are also working in various stakeholders, supporting the Kenya Red Cross Society with the technical working group in terms of generations of the flood early warning system to aid their response strategy. And we are hoping that next, with this kind of information, reductions of flood risk is something that we can deal with in this present time where the climate is changing, is becoming a little bit variable and predictable. We think that this kind of information can be useful in terms of the decision-making process. Next. So in doing this, different organizations that we work with, we do capacity building on the use of such platform for different organizations in both Kenya, Uganda, and Tanzania, and Malawi, where we work. And building this capacity, it means that people understand how the process, the system is built, how it can be utilized, but also critique and provide an input in terms of how we can improve it. Others, thank you so much. I would welcome any questions with regards to that. Thank you so much. Okay, there's no any question? Okay, thank you so much. Okay.
One of the challenges we have in terms of validating models is getting the real-time data. We have very nice models, and we have worked with Earth observation data. We have worked with images. But getting data that can, match with the time of scenes is usually very difficult. Do you do data sharing? Can you be able to provide that in situ measurements to people who want to validate their models?
Thank you so much. I think the data we can provide is the data that we have used to validate the model, because this data are either obtained from satellite or different organizations that you're working with. But also, most importantly, I agree with you, the data scarcity in the region is a point of concern, especially with issues of the climate variability and uncertainty that will engage the region. But the first thing that we did is, where do we get the data to calibrate the model? And that is when the first data that we stop at is the Dartmouth Flood Observatory, because they monitor the flood occurrence in terms of reporting, but not in terms of magnitude, in terms of geospatial locations of where the flood has occurred, the number of people that are impacted. So we would compare our model performance in terms of generating the steam power in those locations where Dartmouth Flood Observatory has polygons. And I've provided in one of the slides there, those polygons, especially the one that are provided for East Africa. The second part is to collect in situ river flow data from Water Resources Authority, from Ugandan Minister of Environment, Tanzania Minister of Water, so that we'd be able, to, one is to look at our stream power and how it performs against the in situ measurement. We have found certain variances that exist, while in terms of reproducibility of the flood hydrograph, I think that is accurate. We have missed the magnitude, but in terms of occurrence in phase, I think that is very much within the accuracy that is needed. The second bit of it is because that we are looking at a bigger footprint, while the flood is local and it is river basin based. So we're trying to regionalize, do a frequency analysis for major flooding river system. We have started with Kenya, that it's Nzoia, Nyando, and Tana River, where we have created, through a rigorous flood frequency analysis, we have regionalized these rivers and determining the flood levels that we would first put into the model so that on the basis of those river levels, we can get an alert, and then we can use those alerts. Now, once it has happened, we can say the alert was issued, but did it happen, so that we can evaluate the number of miss or hits and misses that we can have with our model. I hope that's adequate for that. Okay, thank you so much for your time and for listening to me. Thank you.
Thank you very much. I think we can give him a more hearty clap. So now, yes, the next thing is, of course, to build the capacity, because once we have been able to develop models and validate them and calibrate them and ensure that they are performing, then the rest of the sector, especially the ones in the institutions, we need to do more capacity building in terms of data acquisition and model calibration, so that we are also on the same foot. Duplication, because they have a site, we also have other sites, and the same can be duplicated by other institutions. So thank you very much, Calvin, for that very nice presentation. And I want to go straight to the next one. It is by Charles Muangi, but Charles Muangi was represented. So Charles Muangi was represented by someone else. I think you tell us his name. Yes, Samuel Naina from Kenya Space Agency. I think it is one of the newest big organizations we have in this country, dealing with space issues, data acquisition, program development, and he will tell us more so that I don't water down what he wants to say. So welcome.
Good morning. Good morning. My name is Samuel Wenena Kamau. I work at the Kenya Space Agency, and I'm the one who is representing Mr. Charles Muangi. He's our senior, and he was the one to present this, but he was held up somewhere else, and so he sent us here. So Kenya Space Agency, like the speaker said, we are a very new agency. And we are working towards improving the use of spatial data around the country. So our mandate is to promote, coordinate, and regulate the space-related activities in Kenya. So I hope So today I'm going to have a very short presentation, and our presentation will be based on, we have talked a lot about data and how we can use it, but we have not talked about platform. So today, maybe we are going to introduce a platform that is known as Google Earth Engine that we can use to process, and we can acquire data, spatial data, we can process it and analyze it. So mostly we're going to talk briefly about the Google Earth Engine. Maybe after this you can go and try to use it if you get interest, but I hope that you will all be interested in trying it out. Shared by So as we wait for them to share our presentation, I'll just give a hint of what Google Earth Engine is. It's a cloud-based platform where you can access data and process it using JavaScript and Python codes, and you can access the Landsat data, you can have access to Sentinel data, the MODIS data, and maybe and perform all the processes that you need to. So our presentation is on water resource assessment and the use of GIS and other observation tools. So the scope or what I'm going to talk about maybe is about the Google Earth platform and how we can use it to perform land-use land cover maps and perform water extent and quality. Just some introduction about why water is important. And as I've said, that the Google Earth Engine is a cloud-based platform that you can use, or you can access data and perform your analysis on the platform without the need to download the data. The interface of the platform looks like the photo that you can see there. Then I've said that we use the JavaScript and Python codes to access the data and process it or do the analysis that you need to do. And the data available on the platform are some of the data that are available are the Landsat, the Sentinel, the MODIS. We also have precipitation data. So when you want to use the data that you want to use, you just query and it brings, you choose from the list of the data that they use. So in our analysis, we just chose Lake Nakuru as our area of interest to do some few or some small activities so that we can be able maybe to show or to present here. And our classification list, we had settlement, we had vegetation, bareland, and wetland. Then these are the products that we have generated. We have land-use land cover maps. We use the indices, the M and DW to enhance the the lake or to get the water. We have the NDTI maps. The NDTI maps, the normalized difference turbidity index, mostly helps in assessing the water quality. Then on the Sentinel side, we still have the land use, land cover maps, and we have the areas. Okay, we can be able to calculate the areas using the same platform. Then the time series chart showing how the quality of water has been since or in a certain period of time. So those are some of the land use land cover maps that we had. We have, using the LADSAT, we have the 2000, 2010, and 2020, and maybe even by visual you can be able to see that there has been some changes within that period. Then we have the MNDWI maps and the index, the index for the modified normalized difference water index uses the green and the shortwave infrared bands to enhance water features. And those are some of the maps that we got from when using that index. And that, I don't know whether it's playing, it's an animation. What happened? It's an animation showing the time series or how the change has been occurring in different times. So you can be able to see how the change has been occurring in Lake Nakuru since 2000, using the 2000 map, 2010, and 2020. So I don't know whether it's playing. I hope it is. Yeah, you can be able to see that is 2000, 2010, and 2020. Then the NDTI, the normalized difference turbidity index, and for this we use the red and green bars to show how the turbidity has been. And the higher the turbidity, or the higher the value, higher value show high rate of suspended matter in the lake. So those are some of the turbidity maps. We can see that in 2000 compared maybe to 2020, the lake was more clear or had more clarity than what we have now. So maybe that is somewhere that we can be able to research on why it has been like that. Then on Sentinel data, we classified or we used the same land use land cover maps and then masked to get the map that is on the extreme side, so that maybe we can get only our area of interest, which is the lake. And from the masked areas, you can be able to show, or you can show the areas of maybe from non-water and then water. And although my bar graph on the other side, they don't have the same scale, you can be able to depict that the area of the lake has increased over time. I don't know what is happening with. So also, when you are getting the bar graphs, you can also be able to download the CSV file format and maybe show the areas, these areas are in hectares, and show how the change has been. The non-water are the other classes, and then the water, you can see between 2019 and 2021, there has been some increase. Then we did some turbidity time series for 2019, 2020, and 2021, and we can show which can be seen from the graph there. And also you can be able to get CSV values of representing the turbidity rate of all the time since 2019, but we just choose a small file to present because it was a large CSV file. So the higher the values, you can see the higher the values show high values, show high turbidity rate. So our presentation mostly was to show that we have another platform. I know there are so many platforms that maybe we are using to perform GIS and process spatial data, but we can also still try another one, which is the Google Earth Engine. If you have not tried, you can at least try and compare the platforms. But the Google Earth Engine, the good thing about it is that you don't have to download the data that you need, space. So you just work on it in the platform. So thank you for giving us that chance.
Samuel, for that very nice presentation. I think we can give the audience ask some questions. If anybody has a question, you can ask. Yes, microphone. There's a question there. So we will allow maybe 2 questions in the interest of time, then we proceed.
My question is it difficult is it a must that you know the programming language? Because you say you are using JavaScript language.
Okay, you don't have to know all the programming, but at least you can know the basics. The basics of maybe programming with JavaScript, and then as you continue practicing and doing the processes, you get to know. The most important thing is to know what you're supposed to do, because there are some in the platform there are some leads where if you want to do something, you can search and see how you can do it, and then you just apply that. So you don't have to know all the JavaScript, but at least you have to have some basic understanding of the language.
So I think, okay, there is one more question, and that will be the last.
Sorry, maybe because the microphone was just right here. Mine is, I just wanted to know about the capacity building coming from Kenya Space Agency. I am aware that Rwanda is already having some two nano satellites, which they are utilizing for agriculture and for utilizing for agriculture and also for communication to support primary schools and secondary schools. I know Kenya also have launched some nano satellite from the University of Nairobi and Japanese organization. So my question would be wondering whether this capacity building will be helpful to us so that we do not download Landsat satellite images, download maybe satellites which are available. Can we utilize? Is it a direction that you have that we shall be utilizing these satellites or not? Thank you.
Okay, I'll try to answer that, but the Kenya Space Agency is it's trying to build capacity along or in the country, and we collaborate with other government agencies. If you have a project, you can write to the Kenya Space Agency, and then they'll direct you. If you need any assistance, if you want collaboration to perform or to do any project, we do help. And on outreach, we are trying, like you have said, the nano satellite program. There are those, I don't know so much about it, but I know that they are trying to do the outreach program to the universities and such, so that we can see how we can develop those sensors and such. So if in your agency or your company or your ministry that you have a project that you feel that Kenya Space Agency can assist, we do that. You just need to write to our seniors, and then maybe we will assist. Thank you so much.
Him a more hearty crap. Yes, I would have liked to ask a question about accuracy assessment, especially in relation to RadSat and Sentinel, because temporary and spatially, I think Sentinel is much better. Landsat is a big course, and probably you could compare the same area and see what would be the accuracy assessment in terms of those two. Anyway, so because in the interest of time, I think we want to call the second person, the third person, Ogembo Vincent. If he is here, Ogembo Vincent. If he is not here, we go to Odero Dan. Odero Dan. Very good. Odero will introduce himself much more. He will say where he is coming from, the institution, what they do there, and then go straight to his presentation. We are saying a maximum of 10 minutes in the interest of time, 5 minutes for questions, and then we invite someone else. So his presentation is about application of Earth observation and GIS in borehole site location. Welcome, Mr. Odero.
Good morning, or is it afternoon? Afternoon, I think. Dan Odero from a company called Jurama Engineering Services. We position ourselves as people who try to support architects, engineers, environmentalists to solve unique problems. Now, my presentation is actually a very simple one, just to show how we can apply all that we've talked about since morning to solve everyday problems. One of these is in terms of water resources assessment, okay? How would you, easily locate your boreholes in the right place to maximize on yield? Okay, thank good I can actually control the size myself. So, excuse me, right goes next slide, left. So I point here, this way. So, now I'll just give some examples. As you can see there, water is the first problem. And this is in Tsavo National Park, where we have elephants grazing mostly in the Tsavo West because it's near Chulu Hill, so there's more water and the pasture gets finished, okay? Tsavo East is drier, okay? And what happens is then you've got a time when there is fodder in Tsavo East, but there's no water, okay? So animals, sometimes die during drought. So the issue was how can you provide water in Tsavo East, okay? And because it's a vast area, it's a bush, what you want to do is to try and be as accurate as possible with your sighting. You don't want to waste a lot of time, You don't have the liberty to move around in the bush in a park, okay? It's bushy, it's thorny, there are wild animals. So you want to be so precise that you go and spend the least time on the ground. So basically what you're trying to do is to actually get your site in the office at your desk. Just go to confirm in the field. So that's a map of the park. The red dot is where we were interested in, to provide water in that area. And the site name is Tabagunji. There's no village, it's just within the park, it's just a name of that area. And so when we were called by the client, then we had to go and basically use, as you heard about Google Earth Engine, simply sit in the office with them and then discuss the areas that they like to, have the water placed in. And this depends on the wildlife routes of migration, because then they move from one water source to another as the seasons go by. So as rain falls, forms natural pools, these dry out after some time, okay? So how could we have more permanent water, okay? Recharging these pools so that animals don't have, to go off their routes of migrations. So we sit with them and then they show us the areas. So after we do this, then what we do is using DEM, 30 meters is good enough. Then it gives us a good view of the area that we're dealing with in terms of the land, or landforms and earth processes. So what's happening is what you see is basically the Yatta Plateau, and below it we have the plains, okay? And as you can see, what we've done is to do basically fracture trace analysis, because we know that it's the fractures that control groundwater movement, okay? So once we do that, then we are able to identify which are the areas which are likely to have the highest hydraulic conductivity. So once we do that, then we go back and we get our locations that we'd like to go and survey in the field. And so we get certain locations and then fly out with a team to actually now just a fly past to see the particular areas and confirm, yes, these are the sites that I think we can choose that one. Maybe go to the next one. The fodder here looks a bit okay. Then we go back to the office and then look at our DEM again and see of those areas that we spotted in the air, which is likely to give us, the best yield. And so I see that there's an area, the one circled red, it's near an identified fracture. Then the next thing then is to take the team out now and do what we're talking about, the validation, the ground confirmation, okay? And so basically what we've done, sorry, let's it's gone. Yeah. What we've done there is to try and pinpoint the site so that you spend as little time as possible on the ground. So what you see on the left, like a graph, is what we call a horizontal electric profile for hydrogeologists. Basically, you're trying to identify a fracture on the ground, okay? You've already identified it in the office. You noted its location, come on the ground, and now identify it physically on the ground. And as you can see, basically, it was a very short one, only 8 stations, and we identified, our fracture. So from that, do your survey, and voila, you have your site. Now, that was, let's say, a very wide area. Suppose you're dealing with a small space. Now we have a real estate development, okay? They're designing a park, industrial park, a large estate, and you want to have locate site for groundwater. So you want to locate site for boreholes. But you see, your water has to come first before the development. You must secure your water. Do you have enough water for what I'm going to do? So and then it means you must locate them at a site whereby in the future they can be maintained, they can be serviced. It's not, and because sometimes it's a phased development, you don't put your borehole whereby in the coming years you want to put this building here, but there's a borehole on the site. See that? So then what we do is we work with the architects. They would give us like their layout plan of the site. Okay? Basically a block plan of what wants to go where. And then like that's an example of Africa Logistics Park, which is at Rironi Tilisi. So once we get that, then using the terrain model, we overlay that site on the model and then identify again our groundwater flow paths, okay? And once we identify that, then we overlay now the site facilities, on the same. And identify our, water flow paths across that particular site. And therefore, we are now at liberty to be able to select which is the best location, both in terms of the amount of resource we want and in terms of, the facilities within the site. And doing that, then we are able to actually locate precisely because even the level of your borehole has to match with the landscaping which will come in the future, okay? So it has to be very precise. If it's supposed to be next to a car park, then when the other developments will come in, then they should, come right into place. And so we find the GIS and EO very useful in such occasions. Okay, so basically, that's it, the block plan, and with all the fracture traces and the sites where we've located our boreholes. Actually, those ones have been drilled already. We've used this approach to develop a number of water in a number of sites, like the current waterfront, Nairobi Gate, Tilisi, and others, within the city, JKIA, and others. So basically, this is just to share how GIS EO is very applicable in day-to-day problem solving in water resources assessment. I had some 2 posters, I think they're not there. Basically, that's then the end of my presentation. Any questions? Oh, yeah, you bring the posters. Oh, yeah. Basically, okay, so that's a poster of Tilisi. What's happening is it's located actually at the top of the watershed, okay? So how do you get enough water, groundwater, at the top of the watershed, okay? So we had to map, our groundwater flow paths through the fracture tracing, and then locate where the boreholes would be, look at their plans, because this is a 300, 400 acre development being faced. We've been working with them since 2013, and so so already the water sources have been located, so we develop them as time goes by. So it's just an example of how EO is applicable. The other, sorry, can you show the next one? Yeah, that's current waterfront. They had to develop a lake as part of the development, okay? So we did site investigations for the lake, and then had to, again, also find enough, water. So we had to locate 3 boreholes at particular locations to be able to provide that, and it worked well. So basically, it's an example, just showing of how you could use DEM to, be more accurate and to actually not just cite boreholes, but to produce boreholes. Thank you. Yeah. So a question or two?
My question is, how do you use GIS to identify the durability of water during test pumping?
During test pumping?
Yeah.
You may not do that, okay? But what it does is that you are able to assess the groundwater potential, okay? Annual renewable potential in that particular catchment, okay? Then you are able to relate your location within the catchment and see that within this catchment have so much groundwater that is flowing through this place, okay? Like at Elisi, we have to estimate how much water is flowing through that site daily, okay? To be able to estimate that you can get so much. So to get this much, you must locate your sites. So you can basically use it to assess what is available through your location. So that during test pumping, then you can see that you can get good yields. Yeah.
Thank you so much, Dan, for a very nice presentation. As Calvins has said, groundwater is always a mystery. And I'm just a curious student of water. And I'm interested in knowing when you locate these fault lines or what you call fractures, and you intercept the water, are you not jeopardizing the other people who may rely on the water downstream? That is one part. And the second part is some of these groundwater may have elevated levels of heavy metals or such kind of pollutants. Do you take time also to find out the level of pollution before you allow the distribution of this water? Thank you.
Yes, we actually, yes, take time to every water source, groundwater source, the water should be tested, okay? But then even during the location that is signed, then you must look at the water quality. For example, in Nairobi, we have the problem that the top aquifers have a better quality than the bottom aquifers. But now that we are getting to deeper and deeper aquifers because of over-abstraction, then we're getting worse quality because the lower aquifer has more fluoride, okay? Within the city itself, if you look at ammonia, for example, distribution of ammonia, from Kikuyu, Limuru to Westlands, you've got like maybe 4 parts per million. Under the city center, 8 parts. Eastlands, 12 parts per million because of the sewerage, in the city. So basically, we look at all those in terms of providing adequate water. So if we were to do that for you, then we've got to ensure that, okay, which aquifer are we going for and what is quality? There's no point of mixing, getting good water, then you go down and get poor water, then you mix and you lose your quality. But in terms of the groundwater along a fracture, I mean, it's just like a river, okay? You should look at that fracture like your river underground, okay? So we've got people who abstract upstream and downstream, okay? So that's why Water Resources Authority is there, so that when we strike that water and test it, we are only allowed to take a certain percentage per day, okay, so that at least other users can also get to use that water. Yeah, thanks.
Thank you so much.
Welcome.
We have a presenter online by the name of Ogembo Vincent. Ogembo Vincent will be presenting to us an integrated hydrodynamic modeling using spatial-temporal changes in land use, land cover, and socio-economic factors on river basin, a case study that he has done for the river Kuja Basin in Kenya. Ogembo, you're most welcome, if you can hear us.
Yes, I can hear you. I hope you can as well hear me.
We can hear you quite clear. Please just be mindful of your time. Thank you.
I would request to share my video, share my presentation. I would request the host to assist, help me get present my presentation kindly. Yes, I'm kindly requesting the host to put my presentation on.
Sorry, Vincent. The IT is trying to locate where your presentation is.
Or is he able to allow me to present
share.
from my desktop?
Okay, now they're okay. I think it's okay. You can proceed.
Okay. Thank you so much. Now, Vincent Ogembo, Engineer Vincent Ogembo, I'm a PhD student at Jaramogi Oginga University of Science and Technology. But currently, I work for Lake Basin Development Authority. I'm the manager planning, research, and special projects department. And I would want to do my presentation on an integrated hydrodynamic modeling.
Sorry, Vincent. Sorry.
Yes.
Would you just share your screen with us? Because the technical people have no, they can't get your presentation, so it would be kind of you to share your screen with us. Thank you.
And I would request the host to allow me to be able to show my screen.
You're allowed.
2020, and also to develop a hydrodynamic model for the basin. And in this case, the model I'm using is a HEC HMS, and of course there is an HEC EO HMS extension model. And finally, we also to determine the influence of human population growth on land cover and land use in the basin all the way from 1990 to 2020. Yeah, so this is the study area. River Kuja is stretching all the way from Nyamira County. That's where it starts and passes through Kisii County into Migori County and partly Homa Bay County. And you can see the map. The area is about 6,900 square kilometers with a population of about 2.5 million people. So the research data in this case shall include the following for the three objectives. Number one, we shall have a hydrodynamic modeling, which will include meteorological data, and this data will run from 1969 to 2019, and that will include rainfall and temperature. And then we'll also have river discharge, and this river discharge, we will take it at some 4 gauging stations, with more focus on the final gauging station in a place called Muru Bay at the confluence where the river gets into Lake Victoria. And we'll also use DEM and also the basin shape files for the same. Also, objective 2 will require 30 years decadal satellite images, 1990, 2000, 2010, and 2020. Then for socioeconomic factors, we shall do field surveys where we shall administer questionnaires to a population sample of about 120 people. So the methodology will involve integrating those 3 major objectives, and that integration will give us an opportunity to plan and manage then basically the water resources within the basin. Now that water is becoming a problem, yet there is a greater need both domestic, industrial, and agriculture within the basin. So just as I indicated, I'm having my PhD studies. Already I've started taking some data. I've not done analysis, but I longed to share this because it is the application of GIS and Earth observations techniques that would help to manage the water resources within the basin, which is becoming a threat. So the methodology will involve modeling the water resource and integrating it with remotely sensed satellite data, land use and land cover changes with the socioeconomic factors. So we shall use HEC HMS model, which will be used in a rainfall runoff simulation to determine the stream flow generation. So with this, we'll be able to know flooding areas, effects maybe on flash floods, trying to varying rainfall intensities. And also, we also have moderate resolution image spectrodiometer, which is MODIS. The images will be used for a period of about 30 years to determine land use and land cover changes. And also, as I said, the questionnaires will be administered to about 120 households. And that information will be integrated with the changes we find in the MODIS images and also hydrologic modeling system. And finally, that will give us an integrated planning mechanism on how to manage the water resource. So we have a simplified schematic diagram of how the rainfall runoff process will move in the model, all the way from the soil and going through to the precipitation, and also overview relationship between GIS and HEC GEO HMS and HEC HMS, how they relate. So the data will feed into the HEC HMS model with GeoHMS extension, and we'll process it to get information about the basin on which would help to generate the data. Then we have terrain processing. So we, of course, DEM will be used to delineate the watershed, and the process that already started looks like that for the basin. So the results of this will be integrated for sustainable natural resources and land use planning and management. So the basin hydrologic yields will be giving some potential flooding areas, and the study will recommend best mitigation measures to avoid flooding, which already is affecting so many people, a bigger population, when we have heavy rains in the basin. And then the decadal satellite images having changes in the land use land cover systems within the basin for the last 30 years. And finally, some of the social and economic factors.
Hello, Vincent.
Yes.
Be mindful of our time. Please, could you just speed up a little bit? Thank you.
I'm done, actually. I'm done.
Thank you.
Yes, so basically, the results are not yet generated, but this is the concept on how we shall apply GIS and Earth observation technology on how to manage the water resources within the basin. So that is my presentation today, and thank you.
Thank you so much, Vincent. We'll welcome any question to Vincent regarding to the work that is presented. I don't know whether there is a question from the audience. Both physical and even the people who are online. What are the questions? Maybe Vincent, you can go from me. What are the questions? I know the Lower Kuja, you talked about economic dynamics. There's a Lower Kuja irrigation scheme. I don't know how this plays out in your study and how you consider the dynamics around the economy or of the presence of that scheme in that basin.
Yes, thank you so much for that. Actually, about the irrigation schemes and even smallholder agriculture practices within the basin were the basis of this study, because quite a lot of time there was some enough water, but even the river times the water gets lower during dry seasons, and it affects the schemes. And this is what the study wants to look at and give recommendations on how the practices within the region lead to a sustainable water resource within the basin. Hope that
thank you. Thank you so much. That's adequate. If there is no any other question from the audience, thank you, Vincent. Thank you for sharing with us your good work you're doing. Thank you so much. I'll call on the next presenter, a CEO Ann. Is a CEO in? A CEO Ann not available? Then I proceed to Washuli Dina. Washuli Dina? If you're online, just let us know. Robert Chirchir? Robert Chirchir? Maurice Matu? Maurice Matu? Nanjala Emily?
Yes, good afternoon. Okay, so this is my campus project. I was assessing the vulnerability of the Baricho Aquifer to seawater intrusion. I'm waiting for my presentation to be projected. So with data acquired from the Ministry of Water and Sanitation, I was able to map out the borehole locations. So as you all know, 70% of the Earth's surface is water, and only 2.5% of that water is fresh water, and majority of the fresh water is groundwater. So there is a risk posed by over-abstraction of water in the coastal regions. So there is a risk posed by over-abstraction of water in the coastal regions. I can do it without the presentation. I'll just read it from here. But I'd like you to see the maps. So the water supply in the region, most of the groundwater in the region is saline water. And some of the salinity inland can be accounted for by the Mariakani sandstones. Their mineralogy is quite high in salinity, so water dissolves the salts in the rocks. Further towards the shore, the water has been affected by seawater intrusion. And as you can see, I mapped out a few boreholes in the region. So Bahari is the one in white. So the ones in red are the ones that have been affected by saline water. I didn't actually go there, but most of the ones in blue by now are affected and should be red. So I used the Guldit overlay index. So the Guldit overlay index, just like the drastic overlay index, which is used for assessing the vulnerability to pollution, we use 6 parameters. The 6 parameters are groundwater occurrence, the type of the aquifer, whether it is confined, unconfined, the aquifer hydraulic conductivity, the level of groundwater, and the distance from the shore, and the existing impact. Then finally, we have the thickness of the aquifer. So these parameters are assigned with 3 attributes: weight, range, and importance rating. So the larger the high parameters, the larger the parameter value, are assigned high weights, a weight of 4, and lesser parameters are assigned a weight of 1. Then the ranges are divided into ratings that are characteristic to the study area. So as you know, the study area has unconfined aquifers. So you use physiographical data to assign the range. The importance rating is given from 2.5 to 10. So 2.5, 5, 7.5, and 10. A high importance rating shows higher vulnerability. So here are the results. So for the groundwater occurrence, most of the Baricho Aquifer is mainly unconfined, so it was assigned a rating of 7.5. As you can all see. Then aquifer hydraulic conductivity. The region has a high aquifer hydraulic conductivity. It ranges from 3750 to 25,000 square meters per day. And it is assigned an importance rating of 10 because that is high hydraulic conductivity. Then the height of groundwater above the mean sea level. So the sea level, the column of groundwater above sea level in the region ranges from 3 meters to 40 meters. And this height is adequate to create a hydraulic balance between the ocean water and the water in the aquifer. So once the water in the aquifer drops, the balance is lost, and the ocean water seeps into the aquifer. And it was assigned an importance rating of 5. Then we have the distance from the shore. Most of the boreholes in Bahari are within a proximity of 500 to 500 meters to 1.5 kilometers from the shore. Therefore, they were assigned an importance rating of 7.5. The distances were calculated using the NEAR tool in ArcGIS, as shown in the map. So the thickness of Baricho Aquifer. Baricho Aquifer is about 40 meters to 50 meters thick, and it was assigned an importance rating of 10. Then the final results, we have a formula where we multiply the weight of each parameter by the importance rating that was assigned. Then you add the total and divide by the total weights, which came to 14, and the values of the various parameters have been multiplied and added respectively and divided by 14. We got a value of 7.68. Then the results are assigned, they are rated from 0 to 2.5, 2.5 to 5, then 5 to 7.5, and 7.5 to 10. Ours are within the 7.5 to 10 rating, which means that the aquifer is very vulnerable to seawater intrusion. Conclusions is that the aquifer is it's moderately to highly vulnerable to seawater intrusion. Yeah. Thank you.
Thank you so much, Marcus, for the presentation. You can take questions. Yeah. So any question for Marcus? This is for both physical and the present. So if someone online would like to ask a question, please go ahead. From the audience present.
Okay, thank you.
We're going to have online will be Sirika Girgin from ITC Sirika, if you can hear us, would you just confirm? Sirika?
Yes, good afternoon.
Good afternoon. The floor is yours, please.
Thank you very much.
Yes, we can.
there will be also a help desk service.
Hello, Gregin. Can you hear me?
Yes, I can.
Would you just speed up a little bit? We're running out of time, please.
Sure, of course. It's almost finished.
you are interested to use the platform, please follow the call so that you can apply your research project. And you can find more information on our web portal and social media accounts. Thank you.
Thank you so much, Grigin, for the Earth Observation Africa presentation. I don't know whether there is a question from the audience. Yes, Patrick.
I wanted to ask a question. My name is Patrick, about the R&D facility that you're developing or setting up, whether the data that will be provided will be for only institutions, because you said that you are doing this to support organizations for research and financing. We wonder if this facility that you're developing will also be available for people to use, and whether the data will also be freely available, especially the real-time or near real-time data. Thank you.
Thank you very much for your question. So the data in fact the Copernicus data, mainly the science conditions, which are already publicly available. So through the innovation lab facility, we will provide also facilitated access to the data, but the data itself is in fact already public. And the facility itself is targeting the research groups, so it is more oriented towards research and development. But if you are interested, of course, if you contact us, we can also provide access to the platform for teaching purposes, if it's possible.
Thank you so much, Grigin. Maybe a mind from the extensions. We have quite a number of postgraduates and students. I don't know how they're most likely to benefit from the coming call, or the call is only restricted to PIs. Would you just give us some information regarding the coming call in September and October?
Yes. We don't, for the time being, the rules of the calls are not set, but we won't have limitations, probably from application point of view. So the students are also welcome to apply. One criteria is to have research tandem. So it should be African and European research organizations together. So my suggestion could be to look for partner organizations in European research organizations like the universities, if you are interested, because that will be a requirement. And the second requirement is the topic. So the topic should be either water scarcity or food security.
Thank you so much, that is clear. Thank you so much for sharing EO with us. I'll now proceed to the next presenter. The next presenter will be Margaret Kasuki, presenting to us on determination of causes of reservoir sedimentation using GIS and remote sensing, a case study of Kalundu Dam in Kitui County. Margaret? Thank you. I've been corrected that Margaret is chairing another session the other side. I'm not sure on who is available now. Okay, we'll have Patrick. Patrick will share with us the work that he's doing on the use of GIS and Earth observation for groundwater modeling, a case study of the Kenya Rift Valley Aquifer system. Patrick, the floor is yours, please.
Thank you, Bwana Chairman. My name is Patrick Murunga. I work here at the Kenya Water Institute, and I'm glad that I'm about to share with you some of the work that we did for modeling the Rift Valley aquifer systems. Bwana Wachira, if you can put it up.